Hi everyone. Today we'll talk about the extreme value theorem, a theorem that tells us under what conditions a function obtains its absolute minimum and absolute maximum on a closed interval. In the first exercise, we must identify the absolute extrema of the following functions on the interval from -3 to 3. If you would like to try this exercise on your own, stop this video now and download these notes using the link in the video description. Remember, absolute maximum is the largest value the function takes. Absolute minimum is the smallest value the function takes. In the first picture, the largest value the function takes occurs at 3 and equals 3. The smallest value the function takes is -2, and it occurs at -3. In the second picture, absolute maximum occurs at 3 and equals 2. Absolute minimum occurs at -1 and equals -3. In the third picture, absolute maximum occurs at 1 and equals 3. Absolute minimum occurs in two different places. It occurs at -3 and at 3, and the value of that absolute minimum is -1. Let's see 3 more examples. In the first example, absolute minimum is -2 and occurs at -3. This function has no absolute maximum. We will say that the absolute maximum does not exist. This is because it appears that the largest value of this function on the interval from -3 to 3 should be 3. However, this point is missing, which means that this function does not take the value of 3 anywhere. There is a value of -1.5, there is a value of -1, the value of 0, the value of 1, the value of 2, the value of 2.5, the value of 2.99, but this function actually never gets to 3. This function has no largest value between -3 and 3. In the middle example, it appears that the absolute maximum should be infinity. This function keeps growing larger and larger. However, infinity is not a number. An absolute maximum must be a number. In this case, we say that the absolute maximum does not exist. Similarly, absolute minimum does not exist. In the last case, we have absolute minimum. The absolute minimum of this function is -2, and it occurs on this entire interval. The values of this function on the interval from -3 to -1 are always -2, and that's the smallest value this function takes. Absolute minimum is -2. This function does not have the absolute maximum, and that is because this point is missing. The function takes larger and larger values here. The value, let's say here, is 1.1, the value here is 1.5, the value here is 1.9, and those values get closer and closer to 2, but they never get to 2. So there is no largest value on the interval from -3 to 3. There is a difference between the first 3 graphs and the second 3 graphs. All the graphs at the top had their absolute maxima and their absolute minima. They attained their absolute maxima and minima. The 3 graphs at the bottom had some maxima, had some minima, but some of those did not exist. What was so special about the first 3 graphs that ensured that the maxima and minima existed? That special feature is the continuity of the function on the interval from -3 to 3, starting at -3 and ending at 3. Note that all these functions were defined between -3 and 3, and they were continuous between -3 and 3. That feature was not present in the bottom 3 functions. The first function is not defined at 3. The second function is not defined at -3 and is not defined at 3. The final function, even though it's defined between -3 and 3, is not continuous on that interval. Extreme value theorem says that if a function is continuous on a closed interval from -3 to 3, which means it's also defined all the way from -3 to 3, then an absolute maximum and an absolute minimum will always exist. Extreme value theorem says that if f is a function that is a continuous function on a closed interval AB, then f attains both an absolute maximum and an absolute minimum on an interval from A to B. The extreme value theorem is an existence theorem. It tells you that absolute maximum and absolute minimum exist, but the theorem doesn't tell you what they are or where they are. Let's see if we can determine if we can use the extreme value theorem to conclude that the following functions have absolute extrema on the interval from -2 to 2. If you would like to try this problem on your own first, stop the video now. Remember, we must determine if we can use the extreme value theorem. To be able to use the extreme value theorem, we need to know that the function is continuous on a closed interval from A to B, starting at A and ending at B. In our case, A is -2, B is 2. Is the function x to the third power minus 2x continuous on the interval from -2 to 2? The answer is yes, this function is continuous on the interval from -2 to 2. And that is because the function x to the third power minus 2x is a polynomial, and polynomials are continuous everywhere. Because this function is continuous on this interval, this means we are allowed to apply extreme value theorem and conclude that this function has the absolute maximum and has some absolute minimum on the interval from -2 to 2. What about the function sine of x minus cosine of x? We know that sine of x is continuous everywhere. We also know that cosine of x is continuous everywhere. Subtracting two continuous functions gives you a continuous function. This means the function sine of x minus cosine of x is continuous everywhere. In particular, it is continuous on the interval from -2 to 2. This means that extreme value theorem applies. This function will have some absolute maximum and will have some absolute minimum on the interval from -2 to 2. What about the function 1 over x minus 2? This function is not even defined at x equal to 2. Let's say that this is not even defined at x equal to 2. You cannot plug in 2 to this expression because then you would be dividing by 0. Because this function is not defined at x equal to 2, it cannot be continuous at x equal to 2, which means this function is not continuous on the interval from -2 to 2, implying that extreme value theorem cannot be applied. I cannot use extreme value theorem to conclude that this function has some absolute max or min on that interval. In part D, the function is defined all the way from -2 to 2. This function is defined for all the x's. However, this function has a discontinuity at 0. This function has the value of -2 for x is less than 0, and then has a value of 3 for x is bigger equal to 0. There is a discontinuity at x equal to 0. This function is not continuous on the interval from -2 to 2. Because it is not continuous at 0, I am not allowed to apply extreme value theorem here. Because I could apply extreme value theorem here, I know without seeing the graphs of these functions that both of these functions will have maxima and minima on the interval from -2 to 2. Let's see what they are. Here is the polynomial. That polynomial, as we expected from the extreme value theorem, has some absolute minimum and has some absolute maximum on the interval from -2 to 2. The function sine of x minus cosine of x as well. It has some absolute maximum and it has some absolute minimum on the interval from -2 to 2. We said that we cannot apply the extreme value theorem to these two functions. But just because we cannot apply the extreme value theorem to these two functions does not mean that these two functions don't have absolute maxima or absolute minima on the interval from -2 to 2. Let's see their graphs. The function 1 over x minus 2 has the absolute maximum, but it does not have the absolute minimum. The function that was defined piecewise has absolute maximum. The absolute maximum is 3, and it also has absolute minimum. That absolute minimum is -2. The function does not take the value of -2 at 0, but it does take the value of -2 at any point between -2 and 0. Which means when the extreme value theorem does not apply, the function still has a chance of having the absolute maximum or the absolute minimum. You can think about it in the following way. When someone says, "I love you," they love you. If someone doesn't say, "I love you," they can still love you, they just don't say it. The same thing here. If a function is continuous on a closed interval between -2 and 2, this function will have the absolute maximum and the absolute minimum. If the function is not continuous between -2 and 2, we don't know. This function can, but doesn't have to have the absolute maximum or the absolute minimum.